Hi guys, welcome to this session. Today we will discuss about recursion in Python. Recursion is a very important topic in Python and it's very intuitive also to know about this since it helps you to increase your thinking capability so that you can code tough logical problems. And it's very interesting topic also. So what is recursion? Recursion is a process like where you are defining something in terms of itself. For example, you have a function and you are calling that function again and again inside the function. In simple words, it is a process in which a function calls itself directly or indirectly. So it will be more intuitive to know through coding. But before jumping into coding, let me tell you about advantages of using recursion. Recursion is very helpful because you can make a complicated function very easy short into subproblems. And sequence creation is simpler through recursion than utilizing any nested iteration because nested iteration is very hard to understand. So sequence creation becomes easier, simpler. And code looks simple and effective through recursion. But obviously, actually, it's more complicated. It looks simpler, but it becomes more complicated in a way to think how it's actually working. But if you know the process, it's very easy also. I'll show you. And disadvantages is the memory problem. It takes a lot of memory and time. And reasoning behind recursion is sometimes difficult to think because as a beginner, I think I have done this mistake also when I came into first Python. I was not trying to build logic on paper. I was simply trying to understand through code. That was a mistake I did. And if you are doing this mistake, avoid it. So let me show you how to understand recursion. But first, let's just write a simple recursion function. So let's say I'm saying simple recursion. And let's say I'm passing a number n here. And what I'm saying, if the value of n is 1, simply return 1. And okay, I need to write else. So let's say else. If n is not 1, simply return. I will say that I want to return this function, simple recursion. And I will say this time it should not be n, it should be n minus 1. And I would like to add n also. So this is what I am saying my function to do. So what it is doing, I'm saying I'm passing a number into the simple recursion function. And if n is 1, return 1, otherwise return n plus simple recursion n minus 1. So right now this function looks complicated because of this statement. So let's just first write, let's say I'm passing a 5 number. Let's see what it gives me the output. Okay, before I think I need to run this. Okay, it's done. So you can see that it's giving me 15. So let's just decode this function working. So I'm simply going to write this function again here once. So my function is this simple recursion. And I'm passing n here. And my condition is if n is 1, it will return 1. And else it will return n plus this simple function. It will return simple recursion n minus 1. This is my function. So what's going on here? Let's just decode now. Let's see how it's working. So I passed n equal to 5. So this statement, like if n equal to 1, it will not be executed because n is obviously not 1. So it will return this value. It will return this value. What is this value? N plus simple recursion n minus 1. So my statement will be, it will return 5 plus this function. simple recursion. It will return n minus 1. N is 5 minus 1, 4. So this will be my return in first call when I will pass n equal to 5. Now I need to go into this function. What's going inside this function? So I'm going to decode this now. What is going on here? Again, same statement will be executed. If n equal to 1, return 1, which is not true. It will not be executed. And then again it will return n plus simple recursion n minus 1. So this will give me n, which is 4 this time, plus simple recursion n minus 1. So it will give me 4 minus 1, 3. Now I will decode this line, what it is doing. So again, if n equal to 1, return 1, and is not 1 till now. So I'm going to again return 3 plus simple recursion 3 minus 1, which is 2. And still I haven't reached n equal to 1. It will give me now 2 plus simple recursion 2 minus 1. 2 minus 1, 1. Now it has reached to the point where n is 1. So if n equal to 1 will be executed, this will be executed now. It will return simply 1. Now if you see, it started here. It started here. So this value is 4 plus simple recursion n minus 1. This is 3 plus simple recursion 2. And this. So what will happen now? Now I will go reverse. First, I entered into the function by n equal to 5. I got this, and then 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 this. I will go back from here now. Now it will go like this. 2 plus 1. It will go 3 plus 2 plus 1. And then it will go 4 plus 3 plus 2 plus 1. And then it will go like this. 5 plus 4 plus 3 plus 2 plus 1. You can see 2 plus 1, then 3 plus 2 plus 1, then 4 plus 3 plus 2 plus 1, and 5 plus 4 plus 3 plus 2 plus 1. And what is this? It is 15. And if you check the output here, this is 15. That's how this simple recursion is working. I mean, if you look at the code, it is obviously simple. But when you saw the logic, it is deep. It is deep. So let me just clear this for now. Now, let's see one another program on recursion. This time, I would like to see Fibonacci series. What is Fibonacci series? So let me just show you on Google. Because, for example, let's say right now you are watching the video and you don't know what Fibonacci series. You may think that, oh, I know this. You don't know this. You may feel low. So let me tell you that it's not that I also remember everything. When you need to do something, you first try to just do Google. So what is Fibonacci series? Here, let's check this platform, Geeks. So it is saying that this is the equation of Fibonacci series. Numbers in the following integer like this: 0, 1, 1, 2, 3, 5. Okay. Mathematical terms, it is like this: fn equal to fn minus 1 plus fn minus 2. Okay. With seed value f0, 1, f1, 1. So what does it mean? It means that it is saying that equation is something like this: plus fn minus 2. So let's say with seed value, which is f0 is 0, f1 is 1. So it means that, let's say n equal to 2, f of 2 should be equal to f2 minus 1 plus f2 minus 2. Means f of 1 plus f of 0. So seed value is F0, 0, F1, 1. And F2 is F1 plus F0, which is 0 plus 1, 1. And if I check the same for F3, which will be, according to this equation, F3 will be F of 3 minus 1, which is F of 2, plus F of 3 minus 2, which is F of 1. It will be F of 2 plus F of 1. And I have already found F of 2 is 1 and F of 1 is 1, which is 1 plus 1 equal to 2. And if I check the same for F4, it will be F3 plus F of 2, which is 2 plus 1. So now if you check the pattern, let me just write one more F of 5, then I will show you the pattern. It will be F of 4 plus F of 3 equal to F of 4 is 3 and F of 4 is 3. F of 3 is 2. 3 plus 2 equal to 5. Now let me show you the pattern. I have got F of 0 is 0. 0. F of 1 is 1. F of 2 is 1. F of 3 is 2. F of 4 is 3. F of 5 is 5. And dot dot dot. So what exactly is happening? Here? My pattern is F of n equal to F of n minus 1 plus F of n minus 2. Means my every term, let's say the third term, it will be the sum of previous two terms. If you check this term, it is the sum of these two terms. If you check this term, it is the sum of these two terms. And if you check this 5, it is equal to sum of these two terms. So this is the Fibonacci series, and I would like to do this in coding. So what I'm going to do is, let's write this in code. So I will say Fibonacci, and I will pass a number n. I want Fibonacci series for let's say f of n equal to 5. And for f of 5, I will check the Fibonacci series. So let's just check. So first I need to write some conditions. I would like to write some conditions. For example, my Fibonacci series is obviously, it is f of n minus 1 plus f of n minus 2 for f of n. But seed value is f of 0 is 0, f of 1 is 1. Means I don't want n below 0. I will simply return n. This is my condition. This is my condition. Okay. Here its condition is not written, but just remember Fibonacci series starts from 0, so you don't want n less than 0. So now, else everything is fine. You just return. Because through recursion it's simple. Return Fibonacci n minus 1 plus Fibonacci n minus 2. This is your Fibonacci series. We will simply return this. So let's check its output. Fibonacci. So now I would like to say for 5. So Fibonacci for 5 is giving me minus 5, which should not be the case. I think I did some mistake here. Let's debug this. Okay. It should not be n is less than equal to 0. It should be n is less than equal to 1. Because if I say n of n equal to 0, it will become minus 1 and minus 2. So you don't want it to become negative. Okay. Let me check that if it's working now. Okay, Fibonacci of 5 is 5. This time it is correct. This time it is correct. So here we have already found it using this. Let's check for f of 4 if it's working fine or not. So let's check for this case. Okay, let's check again for all the cases. Let's say for 3, and let's check corner cases also. It's good to test all the corner cases just to see if your function is working fine or not. Now let's check for Fibonacci. 1 also. In the case of 1, it will return 1. And in the case of 0, it will return, let's check. So, okay, it's returning 0. In the case of this, because if I said if n is less than or equal to 1, return n. So it's working fine. You can see that. Because it will not go for else condition because once it's done here. Yes. So you can see that my Fibonacci function is working fine. Now, as I have showed you by going inside of this function, so I don't need to go inside of this. You can try doing the same thing I did for this function to understand how it's working. And just for one more example, I would like to show you how to do recursion for factorial function. You must have you have read in high school that factorial, what is factorial? For example, let's say 5 factorial. 5 factorial, it was like 5 into 4 into 3 into 2 into 1. So you remember this factorial sign. So we will do this in Python. So let's just see how we can do that using recursion. So I will say factorial, and I would like to get factorial for 5. I need to pass some corner cases here because there is no factorial for negative numbers. So I would like to just say if n is less than 0, print factorial does not exist. So these are some corner cases you must know. I need to pass n here. I did some mistake. Okay. Now there's one more corner case. I will say if n equal to 0, because factorial of 0 is 1, just pass factorial of 0 is 1. Factorial of 0, not like this. I should say here. Yeah. So now I will say else. I have passed the corner cases. Now I would like to say return, or simply just print factorial of n factorial is, and then I will simply return the logic of factorial, which is n multiplied factorial of n minus 1. So this will be my factorial function. I think I missed something. Okay, if in case of 1, I haven't passed if in case of 1. So I can add one more condition here. If n equal to 1, return 1. And I can simply return here also. Well, but let's just go for this. I can simply just say return all the cases because return seems better. And I hope you know when we use return when I would like to store something in a variable. So it looks better with return. I don't need to pass this string here. Let's just return simply this and into. It looks more clear. Okay, this is my function. Now I will just check for factorial for 5. Let's say factorial for 5. And my answer is 120, which is correct. Because if you calculate this, 5, 4, 20 into 360 into 2, 120. So this is my function for factorial, and logic is same everywhere. If you check, you just keep going inside, you keep going inside until a certain condition is satisfied, for example, n1. And once it returns 1, it will keep going, it will try to keep coming up one by one, just like we did earlier. Just try writing logic for this. You will understand the recursion. I tried my best to break it down, and the best thing to learn this is you write the logic on paper, how it's going inside, how it keeps going inside. And just to give you a quick recap, I'm showing you how it worked in this case for factorial. So for example, when I passed n equal to 5, it returned 5 into factorial of 5 minus 1, which is 4. And then this part came into existence. It gave me 4 into fact of 3. And then it gave me 3 into fact of 2, which is factorial. I'm writing short for it. And it gave me 2 into fact of 1. And now fact of 1 we know is 1. We know this is 1. So if you check the loop, it is becoming like this. Fact of 1. And it is 1. And the answer is 120. So you can see here it kept going inside. Once the condition is satisfied, it keep going up, and the answer became this. So this is how factorial worked. I hope you got it. If you like the video, please give a thumbs up, share this video, subscribe our channel, and give a comment. How was the video and what else would you like to see next? Thank you guys.